We had a really good plan not to run late, but at the end, today somehow we drifted. So we'll go now to the next session, which is about smart cities and data. And we have two keynote speakers in here. We've got Chris Cooper, who is here, and also Alan Whitehead, who is hopefully coming soon at the end of the session. Are you ready, Chris? Yes. So Chris Cooper is a co-founder of KnowNow Information, is the principal KnowNow in cities, or KnowNow cities. He's a chartered engineer with over 18 years of experience. There you go, you can see it in there. And Chris has been a really good associate with the university, and we have been working together around how cities could be smarter. And hopefully he will tell you more about it now. Thank you.
Thank you, Baka, and lovely to be here. Thank you, everyone. So yeah, I have been in this industry for a while now, starting off at the birth of the smart city ideal. I was part of the team at IBM, and we'll try and answer this question: will we ever have a smarter city? I wear a number of hats in this conversation, and I'll try and tease them out and tell you. So I'm either coming from this as someone that creates standards for the BSI and International Standards Organization, sometimes as a consultant helping places, sometimes as a mere human being. I'm a hybrid. I started life as a social scientist. I'm now a digital engineer, but I'm actually probably just me, and I'm slightly weird, so apologies. So quick question. How many think yes to this question? Hands up. I might as well. Oh dear. Okay. There is a purpose here, finally. And how many of you think you know what a smart city is? That's cool. Okay, cool. Back, I'll expect that from you. Thank you. So, the answer is no. I don't think we will ever have a smart city. Well, maybe. So that's the social scientist in me coming out. I've gone from a binary digital engineer to there's a lot of big grey fudge. So there's no surprise, to tell the truth. So one of my hats is I'm a member of the IT Built Environment Panel. I'm one of the few digital engineers that's trying to make the world of construction a little bit smarter by using data. And something that's over 5,000 years old is making the same mistakes that my industry of 50 years old plus, still makes, but at least we don't necessarily cause death and destruction as you will do in some construction projects. The thing is that one of the surveys the IET did is they asked their population, what does a smarter city look like? What is a smarter city? And the top answer, it's where the kids hang out at colleges, universities, because they're smart. It's like, yeah, maybe. The second top answer, it's where the best dressed people are, because they're smart. Way down in the weeds was the right answer, which is, it's how you're applying data to make the world a better place. We've got a massive gap, and we're not talking about the 1% here knowing what a smart city is. It's probably 0.11% of 1% that actually has an understanding about what smart means. And we're going to go on a journey to see if we can get a better statement than maybe. So hold you up. So it starts off with us understanding about ourselves and what we want something called smart to be. It's all about data. So I'm a big fan of the Sustainable Development Goals. Why is that? Well, because we're taking away the argument as to what does good look like, because someone's already gone to the effort of got 170 odd countries over many, many years and iterations to say, these are the numbers that we as humanity want to see something good to be. And there's 17 of these numbers. Now, the beauty of humanity and our geography and our space is that one place at one point in our map and another place at another point in the map can have widely different numbers. And then we can have a debate as to why my number is better than your number. That's called politics. Now, the challenge we have is that our community and our citizens, and I'm not talking about you folk here, because you're already part of that 1%, but the rest of us do not have a grip on what our numbers are. They're not part of our vernacular. We don't talk about them. In the latest election that you're seeing in this country, how many of the candidates have ever mentioned the word Sustainable Development Goal? Has it ever appeared in our news feed? Do we consider when we're hitting high global temperatures and this latest temperature rise in this country should be no surprise? Japan's been living with a high temperature for the last few weeks. Before that, it was roving around Pakistan, Bangladesh, and India, the Indian subcontinent. And even in traditionally hot places, you've had extended periods of heat, drought. It is well forecasted. We are having a changing climate. I don't want to get into debate as to why. That's not necessarily important here. The key bit is about having a number. And your number across these SDGs are how you can then start having the debate as to what do you want to do. And the important thing here is that we've got this piece here around the biosphere. And I'm going to talk about that in a few slides' time. But recognizing that our numbers that we have are measuring different things. And then, because we're creating numbers that measure different things, we now need to start thinking around that system. Systems. As a data engineer, I love a system. And we think of the concept of systems, and how do we start explaining what that system's doing? How do we put some numbers against it? And do numbers lie? Or maybe. And then we have this final piece, which is the economy. So the economy makes the world go round, but maybe we need to rebalance what we think good looks like in our economy to ensure that our society doesn't melt and our biosphere doesn't degrade. Interesting things, but picking your number. So we know what our numbers are going to be. You're not meant to read this. The key thing is that on our shift to a more sustainable world, I just want to highlight these two things here, flying and shipping. So the source of this is from UK Fires, absolutely zero. I'd encourage anyone to go and read it. You won't sleep that night that you do. Quite frankly, where we are on our journey is not good enough to achieve net zero in the time frame that we're talking about. But again, this community probably knows that. So the point here is that saying, until we actually understand what our numbers are, and until we actually understand how our journey from where we are to where we're going to get to, it's pointless any of this stuff happening because it's not being debated about. But the important thing is that there's some really smart folk that have come up with some plans, and we need to start discussing these plans and discussing the implications. It all goes back down to what is my number? How do I achieve that? And just to achieve absolute zero by 2050, it says all remaining airports will have closed by 2049, so we're not flying anywhere. I cannot see that happening, but I can see us engaging across continents. Maybe it won't be through flying, maybe it's through vacuum tubes, I don't know. But there will be some major changes to how we are living our lives. But an important one, just on heating, is heating powered on for 60% of today's use. I think that is really achievable if we build better places. But until we actually know our number, we can't really go there. So how do we rethink our approach to using our numbers, and how do we look at doing things slightly differently? So I'm a big fan of Kate Raworth's Donut Economics, because it's rethinking some traditional elements in how we perceive the world of economic growth. It's looking at things in a systems basis. It's putting, remember the SDG piece around the biosphere, and giving it some numbers and recognizing that we've got an envelope to build in. And as you have an ever-growing population, and you've only got a fixed envelope of biocapacity, what's going to be the safe and just space for humanity is likely to become ever smaller. So how do we have equitable use of that rare resource called life-giving goodies, like our food, water, health? And the other thing that we need to also think about is this systems a systems approach, because as we use data to drive evidence, we can start using that data to determine what does good look like to meet my sustainable development goals. And I can then start having those debates as to where do I want my community to actually head. And with that new data-driven, evidence-based narrative, you can start doing some really interesting decisions regarding your use of natural resources, things like circular economy, so using outputs to regenerate and recycle and reuse. So that's all well and good, but there's one thing that communities and cities and places have, and it's not necessarily about having houses, manufacturing, services. And this is the one thing that I get really frustrated about my industry in the technology world. It's all about selling your widget, selling that latest gizmo. These little babies changed our lives, didn't they? But what about us? Yeah? So I need to declare some interest here. So not only do we do some great work and have conversations with backers community at the University of Southampton, another part of our digital world is also talking to the School of Computing. And one of my collaborators is a guy called Dr. Richard Gomer. And we've been working together for the last 6-7 years now, and looking at how do we ensure that us humans have always control of our data. And there's some really interesting research and stuff that he's published around consentfulness. And we created a tool called Consentua to actually help make that happen. And there it is. It's all about choice control. The thing, though, is about the context of us is how do we ensure that we stay in control of our data? And it's about giving us those clear choices. And it's also about making sure that we have that rockstar VIP treatment. But we need to think about it in where technology is going to tomorrow, not necessarily how we're using technology today. So that'll be more automation, you talking to your bot, your personal bot, and your data trust. I'm providing you some solutions now, guys. So this is where we hopefully will end up. And this is stuff that we're working on with Richard and the university in terms of this is the art of the possible. So your bot will say, hi, Chris. Today I have 4 interactions that I've allowed because you've previously been in that place in those circumstances and they've had bits of your personal data. 2 of them I've said no because you've said no previously. But I want that validation because machine learning is quite dumb because actually it wants that constant validation of your behavior hasn't changed over time. And then the final one will say, can you just check this one out? Because I need a decision here because it's kind of unique. You're in a different place in different circumstances. And I'm just getting there's no logic here as to what your decision may be. And you go, no, for that day, because it's my birthday, I could give away more of my data. So yes, they had it for that, but it's one time only. Ask me again. And we need to do this and then at a digital engineering perspective that's very clear, using transparent language that's incredibly interoperable, but also is not using typing because we need to make it accessible. It will be verbal, it will be visual, it will be augmented reality. We're not there yet, but we will be. So that's putting us there. Now we need to come to the other piece, which is understanding the value of data. So the value of data is really key. We came up with this model with Richard, a guy called Jake Verma from the Energy Systems Catapult. And it's around taking, the whole premise is if we generate so much data, and as a data engineer, I hate throwing anything away. But we've got to. Otherwise, you will never afford, to manage that data And we started off and came up with this model as a result of a project on the Isle of Wight. And we worked out quickly, if we wanted to sense every home in the Isle of Wight, we generate a terabyte of data a day. And we only had about a tenth of that as a cost envelope. So the data cost was costing more than the value it would ever be extracted. So how do we get rid of data? And we came up with a way of coming up with a safe way of getting rid of data through the data management canvas. But the important bit is recognizing that as data goes closer to your event horizon, the point where you're going to make that interaction, you've got lots of data. And as soon as it's happened, you don't need that data anymore. You can just take the answer and get rid of all the compute that came with it. Because we could probably recreate that compute data through a model. So the important thing here is knowing where your data value is and getting rid of data, otherwise it becomes a burden. The other thing is making sure that you have AI with purpose. So this is a project that we did with the IET and Atkins, and it's to do with the maturity level of digital twins. Now, we haven't talked about digital twins because digital twins are just like smart cities, something else that's my industry is marketing and going, it's going to save the world. Digital twins are really interesting though, because they give a chance for numbers, those SDGs, to come alive and actually be something useful. The industry will tell you that we're scudding around here and it's getting really exciting. The reality is we're probably mostly at naught. There are some places that are doing some interesting thing with digital twins, but having them self-healing, self-working, and you having a light touch view of what's going on in your world, we're miles away from. And the sad reality is that they're following the same smart city place, which is they're forgetting the context of why they exist, which is about us. But if we take that systems approach, so we look at energy, transport, healthcare, water, food, and urban environment and place setting, you might have a chance in using data to then feed and grow those other things. But let's be interoperable. Let's have sustainable development goals as our number, and then we might have a chance. But all of this needs some way of coming together. And the piece to here is the Gemini principles. Oops. Is the Gemini principles. We've been part of the Centre for Digital Britain, now the Digital Twin Hub. But the premises of those principles are really important. And it's about making sure that you have data with purpose, which we've identified and we could do with the data canvas. Making sure you have privacy by design and consent as a key component, as long as it's about us. It's secure, it's interoperable, and it has some public good. If we do all of those things, we're on to a winner. We might actually have a chance of being smart. So follow standards. There's some great ones out there. And there's also an opportunity that we might be smarter. And final piece, the last bit of tech, is we need to have pervasive, open, interoperable connectivity. And it starts off, and there's one place in the south, bringing it right here, that has that, which is the Isle of Wight. But we also need to think about 5G, great for autonomous cars. That's about it, really. That's another subject for another lecture. LoRaWAN, low-powered wide area networks, so you can get that drip feeder data in from all those magic sensors for the Internet of Things. But ultimately, fibre to the door for every citizen within a short period of time should just be a standard that we expect. We've got more and more data that we want to collect, harvest, and putting us at the centre of those impacts and answers. So in summary, no place is smart yet, but we are on potential to get there. We do need to have a focus on connectivity. We do need to make sure we identify data with purpose. And we do need to make sure that the process and people aspect of any transformation are front and centre, and they're driving the technology and the requirements we need for that connectivity and that data to happen with purpose. And finally, we need to make sure it's interoperable, cyber secure, privacy by design, consent is absolutely paramount, and we remove the silos and we create a systems approach. So on that basis, so thank you to all these people on the left, because they've influenced my thinking, plus place on the right gives me an excuse to talk. And I've been Chris Cooper, and thank you very much.
Okay, any questions for Chris? Well, understood. Chris, so really interesting stuff. The urgency of climate, the impact of climate and so forth. You have been, I think, in this space for such a long time. And since this is an evolving cities conference, which of our cities that you saw the graphics of creating is actually evolving and going on to that ladder to allow us to achieve perhaps some of the smartness to address the climate change aspect?
So my favourite UK smart city is Bristol, but I'm a Bristol rugby fan, so that comes slightly tarnished. If I look at our dysfunctional community here in the south of England, we're not talking the right language, we're not asking the right questions, and our political and executive leadership is not where they need to be in terms of their understanding and educational knowledge of what becoming smart is. There's not the sponsorship in some of the director of services, yes, within their pillars. You could argue that they're doing some really interesting things at county and a unitary level. But as a region, no, we're not there yet. Some of the most impressive international smart cities you'll find in Southeast Asia, Southern Africa, where you're having to do smart decision making off very small budgets, but with a go-to attitude that's making people front and centre, because you don't have the legacy of old ways of working or having to support old infrastructure. And that, I think, is quite exciting. So I would never look at this country as a leading beacon of where something smart has occurred. Where we are very good at is combining all of our expertise and our services and our consultants and working collaboratively. Fantastic. And we've got some amazing thought leaders in this institution. I would say that because I'm working with some of them. But also in other places as well, such as the University of Portsmouth, which has been a big supporter of ours as well with the digital twin stuff. So there is hope from a UK PLC perspective, but yeah, we've got a long way to go.
So I got a follow-on question, then I'll go to Andrew and got another question there. Hopefully you'll just briefly on that. 2004, I think, or something like this. Alan Penn was here on first day. Nick Tyler was here yesterday, not here, but online yesterday. And myself, there was the first ever smart city. It's going to be zero carbon. Was dreamt up by the mayor of Shanghai, Dongtan. I don't know if you've still heard about Dongtan in China. It's one of those really highly one of those islands is sensitive environment, but they really took the challenge to do it. And they invited us to be part of that group to actually look at this. And at the end, what happened is that the mayor of Shanghai put him to prison, and that island did not occur. And then you got the second city, which is announced, was Masdar city in UAE. Yeah. And I remember from the initial stages of that, they're going to be also a smart city. It did not occur. We here, and you were part of that, 2013, yeah. The Future Cities competition, yeah. Which we're going to deliver Southampton to be a smart city. We put in our bid. And guess who won it? Glasgow. Yeah. Glasgow is not a smart city either, right? No.
They've turned off their dashboard.
Yes. So we... Basically, it's almost like some of the renewables I was involved with before, that we promised so much, perhaps not deliver anything. What do you think?
I think we need to learn from that failure. And actually, Glasgow have done some really good things. And I know the team up there. Their focus was on trying to do something really conservative, but probably in too many areas. They did a number of good things about opening up their data. What they didn't do is drive a conversation as to what that meant. So it's kind of a half-baked kind of thing. Yeah. The focus was on creating technology and not using data with purpose. So one of my favourite places is Wellington in New Zealand. A couple of earthquakes really shapes how you deal with natural disaster. So they said, okay, we're going to put PV on people's roofs. If you have a PV, you need to supply a publicly available USB charger. Why? Because when there's an earthquake, the grid goes down, but there's all these power centres.
Yes.
What you're missing is connectivity with people. So if you can get people to charge their phone on a publicly available USB that's sitting outside someone's house, all of a sudden you can get people communicating and starting to do things. We then deregulate the information and go, where is that charger point? It's here. And they create what I call versions of truth that anyone can then pile into, be it Google, what 3 words, your local community. Really smart decisions on deregulating. And where did that idea come from? It wasn't from a geek squad. It was from the community, because they said, do you know what, if we could have done? And then someone smart went, well, let's put the 2 things together.
Yeah, yeah.
So community engagement, that's what we're missing.
Yeah, I think that's great. Andrew, please.
Andrew Waggett, Portsmouth City Council. I suppose just a sort of observation on the ground of doing this. You know, at a city council level like ours, there's not one person who's responsible for doing this. We own 15,500 social houses, for example, right? So it would be absolutely magic to get some really good analytics out of those social houses.
Yeah.
But the benefit stack, if you like, of taking that data out is smeared across public health, the social housing provider themselves, the service providers, etc., utility companies, etc. How do you? Are there any good examples?
We lost sound.
And then moving those other nice to haves in due course, because it feels a crime shame that every single time you put a piece of smart inverted commas tech into something, that it sits in isolation from absolutely everything else that's going in there.
Yeah.
It goes into one particular region and that's it. And you're missing out on, you haven't effectively paid the data out for every single sense.
Yeah. So if you didn't hear the question, it's how do you break down silos? And how do you reuse smart? So there's 2 answers. One's called ICEC2022, a framework for interoperability, and it gives you a whole bunch. Again, I declare I helped write it, so I'm a big fan of it. But it came from a collection of different experiences and from many, many stakeholders. It's been implemented in several places, not in this country though, I hasten to add. But what it does, though, is it encourages you to break down silos because you create an information marketplace. And it gives you a value of the data, and you have certain rules of making that data free and open and interoperable. Now, just because it's open doesn't necessarily mean it's free to consume and use. You might want to put a tax on it, and that's what a marketplace encourages. So where it can be exploited for free, you do it, but it also encourages you to have governance. So the other piece that you need to have is good procurement, and making sure that you have good rules of engagement to those communities that are going, can I put some sensors on this place? And then you share the data and create these versions of truth. Now, just because it doesn't have to be all owned by the council, it could be sitting over there because it's energy, it could be sitting over there because it's relative humidity, but the health centre can go, oh, I can see that you've got respiratory problems. Maybe it's your home that you're living in that's causing that. What interventions can I make? And write a prescription, not for you, but your house.
Just an observation on that is that it's also great to create this data, but it's having those data recipients being able and wise to actually using it on the other side as well. So, you know, if we send boiler fault codes to a service provider at the moment, they'll just turn up and do things the way they probably ever did.
Yeah.
If you send it to the local NHS trust, I don't know what to do with it. So it's also convincing others, I suppose, within that supply chain or within that web to use that.
And there's something called the UK Smart Cities Network, which is only open to the public sector. And it's run by a lady called Jenny Nelson, used to be run by a guy called Nathan from London. Jenny Nelson's at Newcastle, and there's a city called Hull and a guy called Adam Jennison that is unpacking at a city level those data sets. And he's using another standard called PAS 183, which is now can become an ISO 3710 something or other. It's just been released, and that came from another Brit, Jackie Taylor, who's ex-University of Southampton. Mm-hmm. you'll find that a lot of stuff comes from here, in a way. So there is already blueprints that tell you what data to do and how you can share that. But you're right, unless you educate that this data is even here, and that goes back to my point around the people process element, you've got to do a transformation. And the industry will tell you, implement this sensor and your world will be fine. No, implementing the sensor is the end of the beginning of the story. And there's much better people here that can tell you how you get data from a place in a secure way at scale. Nick. And that is just part of it. How you then use that data to make transformational change is where you need to put 90% of your effort. And you only have the first 10% of the budget to actually implement it. So that's why you've got to start small, drive savings, reuse those savings, get bigger. But it's possible, and I'll happily help you because it's my home city.
It's great. Thank you very much, Chris. We would need to have another session on this debate, and I think we could perhaps organize a workshop to get us all together.
Yeah, happily
again.
do it.
Thank you very much,
Cheers,
Chris.
guys. Thank you for listening.
Thank you. Can I introduce Professor Nick Allott from Inquiring Minds, who's going to be talking to us about unusual nature of cybersecurity threats facing cities and strategies to mitigate them. And then I'll hand in the chairmanship to Max.
Thanks, Becca. So, good morning, everyone. There we go. So, I'm going to pick up on a lot of the points Chris kindly queued up for me. But a word of warning, sometimes when I talk about these topics, it can feel a bit like a damp squid, because I'm going to talk about a lot of very tricky problems that are fundamentally impediments to delivering sort of, I think, the common vision we have here, which is sort of like smart cities. However, I think this is all part of the growing up phase and moving from a sort of like research phase to operational deployment. And if we don't consider these issues and deal with them, then the whole thing will just fall flat on its face. But before we do that, just a couple of, I suppose, moans in a sense. So first one, and this is no criticism to back on the evolving cities, but Chris picked this up. How many people actually know what smart cities are? It's quite a small number. Now, my issue is a lot of government agencies across the globe tend to change the adjective and the noun on almost every new project that they create. Now, that is making the problem of communicating widely what smarter is infinitely more complicated. And as for the innovative towns, what was it? The Future Innovative Towns Hub. I mean, taking two adjectives and two nouns, I think that's just greedy, and it's just making the problem so much more worse. So I think if you can start to consolidate and be a bit more consistent with the branding, it'll be much easier to start building up a consensus around this area. Second thing, about the reality of operational deployment as we move from research. This is the UK's public contracts database. This is the number of contracts live. And this probably covers about a 6-month window in smart cities. No opportunities found, okay? Chris and I have been in this area for 10, 15 years. This is the problem we're fighting with. There's a lot of clever stuff going on. Actually, people paying to deliver this stuff, very, very small. But hopefully this will fix itself. So, the main thrust of my talk now, I'm just going to talk relatively rapidly. Usually when I do this, it takes about 4 hours to do it. I've still got about 8 minutes left to talk through some of what the big challenges are and some of the high-level things we can do about it. First issue, so smart cities, just a fact, they are attacked, right? It's happening in the States all the time, and the reason they're attacked is people can make a lot of money from attacking them. And the reason that they're attacked a lot, it's, variations of the same thing. You've got lots of what is essentially critical infrastructure that hits almost every aspect of a person's life, and it's heavily interconnected, and if you can disrupt it, it's going to hurt people, and if you can hurt people, then people can make money out of it. And this is backed up with data. I've just pulled this off the internet. This is just a list of hacks or attacks on largely public sector organisations, some of which are cities, and that's for June only. And those are just the ones that are public. And if you know anything about this type of stuff, that is the tip of the iceberg, because most people do not publicise it. So that gives you a sense of the scope of the problem, and we're really just at the outset. Next issue. In any problem, any security problem, your weakest link is the dangerous bit. And for us, the weakest link is those cheap sensors that we keep deploying. Here's an example. I won't say what company it is. We're involved in them in rolling these out in a particular county. They were doing wireless cameras. They wanted us to help sort of like debug some stuff. And as part of that, we just asked them a few questions. Some of those questions were, well, okay, what camera are you using? Where did that come from? Don't know. The wireless unit, where did that come from? Don't know. The code that's running on and the embedded code is outsourced development. You've got 3 pieces of kit there, very easy to hack if you know what you're doing. Cameras are notorious for being easy to attack, and that these things are being deployed and rolled out in cities, and no one even knows where the actual original thing came from. And it's not really the supplier's fault. The purchaser has to, take some of the can, because the reality is those tenders are issued with a weighting of about 50 to 70% on weighting, so the cheapest tender wins. This is what's going to happen. It's inevitable. And this stuff is operationally connected to the traffic management system. So this tiny little device that's being deployed in cities is going through a chain of connections through to a piece of critical national infrastructure. Which takes on to the next problem, which is essentially the complexity of trying to secure an evolving and highly interconnected system and the unanticipated consequences. There's loads of examples I can give for this, but I mean, I like this one. So this was in the news a couple of years ago now. So as an artist, he basically just put 90 phones in a little trolley and just walked down the street. So what happens? Google thinks there's a traffic jam. If Google thinks there's a traffic jam, it starts routing everybody in different directions. So it just gives you an example. This is someone who actually physically doesn't have access to the city infrastructure, can totally disrupt the infrastructure, and because you can't anticipate the consequences as one thing hits another. Here's the other one, and this is pervasive. This is to some extent the biggest challenge with smart cities, is it's always somebody else's problem. And it's largely somebody else's problem because the reality is people think of the smart city and they might think, oh, Portsmouth City Council, there's one person in charge and it all works. It doesn't work that way. The actual operating infrastructure is incredibly diverse and outsourced to an infinity of different companies. And it's not just the processes, sometimes the physical assets. The physical assets that you connect to are actually owned by completely different organizations in a disconnected sense. And if you want to start thinking about the security problems, you need to start thinking about, well, who owns what? Who's responsible for what, both sort of from an installation perspective and an operation perspective? Who owns the data? So this is a surprise. In so many cities that we've talked to, they've signed contracts that have signed away the rights to their operational data that they use on a day-to-day basis. They then have to go back and renegotiate the contract to get access back to it again. Then you've got the issues of APIs, which is essentially how the data flows, and then going back to the other slide, how does all that APIs flow? How does the data flow between the different organisations? And I suppose also, just a bit of a moan, there is a cultural problem that we'll come to in a minute, but the challenge companies like Chris and Ours face is they really don't like working with small companies. I've accidentally been tagged on email trails from CTOs from council saying, why are we working with these small organisations? So just because you're the big guys doesn't necessarily mean you know the answer to some of these problems, because these are really, really hard problems. Then we've got culture. So CISO, if you don't know it, Chief Information Security Officer. Any medium-large organisation will have them. A lot of councils are billion-dollar turnover organisations. Not many councils have got these people. And why? I mean, it's a major problem. It's a culture and skills problem. This stuff needs to be embedded at the board level all the way through, because the challenge they're facing is bigger than even like even super large commercial organisations have. And where we do have processes in place or security officers in place, there is a tendency within a lot of local authorities to solve the problem with a compliance culture. They give it as a set of tick boxes they can do to the outsourced organisation, and that is not sustainable. It's not good enough. There needs to be overall security cyber ownership of the end-to-end problem. Otherwise, these problems will just get worse. So whistle top. I can't even think what the word is now. Anyway, so that's just a high-level list of the problems. So what practically can we do about it? So I'm just going to give you 3 recommendations here. There's obviously a lot more under the hood. So the first one is, work out what you don't know. So I don't want to get all Rumsfeld here. Maybe that's not the way of saying it. Work out what you should know, right? And the most basic, simple thing every city should do is just produce an inventory and audit of what you've got. In all of the local authorities we've worked with so far, I've never been able to get this list from anybody, and it's the first thing I want. We have to go around and dig it out of the various departments. But what there should be is there should be a definitive list of, what are the sensors out there? The ones, both the ones you own and the ones you use, right? Physically, where are they? How many are they? Who made them? And therefore you can work out what the risk is ascribed to it. And that's just at the sensor level. But then you really need to do the same for all the databases and all the major workflows. Because only when you've got that complex system map do you have even the slightest chance of being able to secure it. And it's a relatively simple thing to fix. It's this an inventory and audit of your primary sensor and data assets. Next thing is, Chris touched on this in a sense. So it's a security concept of least privilege. It's a well-known, understood concept, and basically what's it saying? What it's saying is when you do something, give them the minimum amount of information needed to do that thing. And it's a principle that really needs to be applied everywhere. Sort of consent, GDPR are, in essence, facets of the same thing. But this thinking really needs to be embedded systematically across the organisation. And I'll caveat that with saying this is true at an operational level. At a research level, you can fudge the edges a little bit, and you need a little bit sort of like broader thing. But this is my problem. There's a lot of organisations out there essentially selling the concept of a data warehouse, a data lake, a data observatory. Don't do that. It's the worst possible thing you can do from a security perspective. You've said this is the opposite of least privilege. This is saying, I want to answer all the questions in the world and the ones I haven't even thought of yet, and I need all the data. Let's put it all in one honeypot. Right? That is not what you do. What you do operationally is you work out, for this transaction, what's the minimum amount of information that I need, and then put in place the processes that reduce that threat boundary. So the final one is another security principle. So this is net zero. This is zero trust. This is what the cybersecurity equivalent. It's a complex thing. It's being promoted quite heavily both by US and UK sort of cyber agencies. And basically what it's saying is don't make stupid assumptions, right? When it comes to security, don't make stupid assumptions based on perimeter. Check everything, validate everything, continue to check everything. And the best metaphor I've got is Little Red Riding Hood. It's quite an easy way of explaining what it is. So Little Red Riding Hood, right, when she goes to Grandma's cottage, she doesn't assume it's Grandma just because she's in the cottage. It's sort of the same concept of having like secure enterprise networks. Just because you're on the secure enterprise network, don't assume you're trusted. Similarly, just because she's sort of like dressed up in a dressing gown and glasses and that type of stuff, that's not enough. You need continuous validation, right? Eyes, ears, mouth, teeth. That's the questions she asks. That's multi-factor validation, and you're constantly monitoring behaviour and checking behaviour. And if you put all of these strategies in place across your system, you're starting to build the basis of the framework that you need to be able to protect all the moving parts of your city. So I did that fairly quickly, hopefully just about in 10 minutes. Try not to be too depressed about all of that. I think these are all positive things. I mean, we as a company do a lot on the cyber side. We also do a lot of analytics work. These are some of the sort of like the digital twin solutions that we're building in this space. But I think the message, and if you're interested in these, come and have a look at the expo. I'm not spending my time in this presentation explaining these. But what I want to emphasize is those underlying security assumptions are the things that make all of these operationally viable at scale. And if you want to mature these technologies from the research phase to the operational phase, I think you need to start to absorb a similar type of thinking. Thank you very much.
Okay, let's jump to our next speaker, Dr. Viviana Bastidas Melo, Research Associate in the Cambridge Centre for Smart Infrastructure and Construction, University of Cambridge. She will talk about a competency framework for leading place-based digital innovation. So, thanks, and the stage is yours. Please respect as much as possible the 10 minutes.
Hello, everyone. Thanks for attending the presentations today. I'm Viviana Bastidas Melo from the University of Cambridge. I'm going to present the competency framework for leading place-based digital innovation. So the co-authors of this research are investigators from the University of Birmingham, the University of Peking, as well as the University of Cambridge. So this is the agenda for today. I'm going to introduce the background, so where is the problem located, the methodologies and the techniques used to follow this, the research, the competency framework as the main output of the project that we are developing now, and the limitations and future directions and conclusions of this work. So Digital Cities for Change is a flagship project from the University of Cambridge, which seeks to understand how city is managed, how the data is managed at the city scale, so how we can generate, collect, analyze, and process this data, and how we can use it to improve the decision-making in the cities. At the same time, this project aims to understand how this data can be used to improve the city planning, the management, the delivery of the public services to improve the quality of life for the citizens. So, but we cannot talk about the digital innovation, the digital transformation in cities if we don't talk about the governance part, the governance element, which is key for developing these kind of projects. So we need leadership. So we need people who can provide efficient, equitable, democratic, and trusted services. And this is difficult because traditionally, public policy professionals and infrastructure managers are trained and work in professional silos. It means that we are missing, for example, the knowledge, the skills, and also the digital tools that can help to provide the optimal outcomes for the communities across multiple sectors. So to address this problem, we follow a socio-technical approach, which considers the social aspects of cities as well as the technical aspects of these emerging and new technologies. So the research team has collected a large amount of data by conducting different workshops and to understand with city councils, city council authorities and practitioners to understand really what are the competency gaps. So what we need to improve and how is necessarily to be managed across these digital transformation projects. So as a result, we propose a competency framework which aims to close these existing competency gaps and to provide the city managers and the city authorities with the competencies that they need to manage these digital innovation projects and to create public value with responsible digitalization in the urban built environment. So, which is important to highlight here is that the creation of public value cannot be possible just if we are not creating this responsibly. So we need the governance elements, we need the ethical considerations, the technology components, and the empirical focus, which in this case is related to the place-based concept, which means that the context where we develop these projects are important. So it doesn't mean that, or it doesn't work that we copy and paste the solutions from one city to another city. So we need to understand the constraints, the policies, the budgets, for example, from different cities, from different countries, and that's why it's important, this empirical focus and the place-based concept here. So the competency framework as well proposed that this digital innovation is not an end process, so we don't need to be smart now, but this is a process that any city can follow, and we propose for that reason a 9-box model, which prioritize different activities and different stages. So we recognize that the strategic component is important, so we have the planning stage, the testing stage, which allow us, for example, to understand which are the different pilot projects that we are developing in the cities, and then the embedded phase, which considers if we need to upscale or not these pilots, because mainly most of the cities develop many pilots, but we need to understand after the evaluation, if it's necessarily, for example, based on the results that are not all the time successful, if we need to upscale or not. And the enable component, which is in the bottom of this 9-box model, which is a supporting environment for these other phases. So to perform these different activities within this process, we need the right competencies. So we need the right resources with the right set of competencies. And we develop, based on these different workshops with the practitioners, competency framework, basically focusing on the action base, which are the abilities that the people need to perform these activities, but also the knowledge-based competencies, which are the knowledge, the concepts, and the methods that are required to develop these projects. So we have 3 different competency clusters, which are the digital and technical, where, for example, we have all the digital technology trends, the technology applications, etc. The governance and management cluster, where we have, for example, the government, the stakeholders and collaboration, the citizen engagement and participation, the business models, and the ethics and responsible innovation, where we have, for example, the anticipation for the impact. And for each of these competency units, we have more specific competencies, where we define more specifically what is necessary to address these digital innovation projects. What is important to say is that as we want to close the gaps, the existing interdisciplinary gaps, so the roles of the new roles that we need to shape for address these digital transformation projects, need to consider all of these elements that we saw in the previous slide. So, for example, we have the sponsor, the catalyst, the champion, the implementer, which are roles that at some point and at a different level need to know, for example, about digital transformation, about digital tools, about the governance and management, but also about the ethical components. So, as part of the limitations and future research, we propose a competency framework which will be continued validated by using different case studies. So we have been working with existing digital twins, for example, the 3D model in Boston. We have been working also with the Lure project in London, and we have been working with some cities in Singapore, where it have been validated, but this needs to be validated more. As the result, we have also identified the different capabilities, knowledge requirements, and competencies, following a socio-technical innovation of urban systems. And finally, the competency framework will be used to create a foundation for designing the qualifications and the training qualifications for a new master course in the University of Cambridge. Finally, the conclusion. So we have, we understand that the digital transformation and innovation in cities is a socio-technical process that involves different components such as people, strategies, that involve also, for example, the processes, the capabilities, and the impact that we produce, for example, in the local authorities are important. So they need to refine and reshape the existing competencies. And these competencies are, as we saw, related to different aspects, not just as a silo competency. We need to address all of these elements by using the socio-technical approach. We have the overall aim of the framework, which is defined as one of creating public value with responsible digitalization. It means that we need to consider which is the impact of this digitalization for the society in terms of the people, but also in terms of the environment. And finally, within this framework, we have identified, as we saw in the presentation, the different tasks, competencies, and the different roles identified. Thank you very much.
Our next speaker is Lauren McMillan, PhD candidate at University College of London, and talking about machine learning-based health monitoring and leakage management of water distribution systems. The stage is yours.
Thanks. So today I'm going to speak about some research from my PhD on machine learning in leakage detection. So brief bit of background. At the moment, about 1/5 of the water that we put into pipes doesn't make it to taps. And on a week like this week, when we're asking consumers to reduce what they use, it's kind of only fair that we expect water companies to do their bit to minimize waste. Part of the problem is that not all leaks look like that. So the two parts that we kind of look at are leakage detection, so knowing that a leak has happened, and also leakage forecasting, so can you anticipate leakage and save water that way. There's been a lot more research on the detection side than the forecasting side. We're trying to do both in this research. So this is the data set that we've got. The big thing to take away is that this diagram in the bottom, how water companies manage their network in the UK is they break them into sort of district metered areas. So this might represent a postcode area or a cul-de-sac type thing. And it can be isolated from the sort of rest of the network, from branching off from the mains. And so most of these have a flow meter at the inlet and outlet. And so we have the flow data for all the DMAs in Yorkshire for a year, and we have the repair logs for the same period. And so what we've done is create a hybrid deep learning framework for leakage forecasting at the DMA level. For the leakage identification side, we've used isolation forest as a machine learning algorithm. And then for the forecasting side, we've got an RNN with Kalman filtering to do the forecasting. Not going to go into too much detail on this, but Kalman filter basically says that what you get from sensors is the actual state of the system plus some noise. And it is a method for trying to estimate that state based on the sensor observations that you have. And a Kalman smoother, you can see it literally sort of smooths the data by trying to remove the noise. You can use a Kalman smoother if you have data before and after a given time period and you want to estimate that missing data as well, which is what we did in data preparation. So this is example, a random sort of DMA. You can see that we have missing data and we have invalid data. So for these sections, we use Kalman smoothing to replace those flow sections. And you can see here that when you then look at the repair log, and you look at sort of what to our eyes looks like sort of spikes in flow, that these outliers seem like they have something to do with repairs. Outliers are often taken to indicate leakage, and repairs are normally taken to sort of indicate confirmation from water companies. They know that leakage has happened either because customers tell them they see it or through looking at their DMA data. Short anomalies, probably not leakage, maybe something to do with firefighting or an industrial event or a sensor blip. But you can see that there's probably some kind of link there. So we used isolation forest, which is a machine learning algorithm, to identify outliers in the flow data. And then we plotted those outliers. We looked at the repair logs for the DMAs, and we looked at, do those outliers correlate with with repairs. So the yellow bars are quite interesting. You can see that quite often there's an outlier right before, or a period of a few days before a repair. So we're sort of happy to assume that repairs are indicative of leakage. So we take those outliers and we say we only wanted outliers that were long enough to probably represent leakage, 5 hours. And we take the preceding flow data. Sometimes that butts up against another outlier, and so we only want the sort of healthy preceding flow data. Ideally, we got a week's worth. Sometimes we got less. We use zero padding to sort of make them consistent lengths for the model. That gave us about 3,500 outlier groupings. We got about 7,000 randomly generated sections of healthy flow. So this is obviously not an outlier. We wanted to train the model so that it could not just forecast outliers, but also accurately forecast healthy flow. So otherwise, what's the point? So for each of those input groupings, we took the preceding data, the non-outlier section, and we broke it down into, using time series decomposition, into a trend component, the overall pattern, and the seasonal component, which you can see that is basically just the daily water use. Like you can see nights and mornings, that kind of thing. And those are the inputs for the recurrent neural network. Again, not too much detail, but basically you put them in, and what it gives you out is a section of flow forecast equal to the length of the outlier or the non-outlier sort of control group. You get a forecast for that period. Again, not too much detail, but the detail for the RNN is that it's made up of these cells, and they have sort of two components: a short-term memory, the previous forecast influences your current time step forecast, but this cell state is almost like a highway, and it allows the important information from many previous time steps back to be sort of brought forward and influence your current time step. So that's an example of one bit of results. So on the bottom left, you can see the RNN forecast and then the recorded data that we got from the sensors. For all of the groupings, we got this, and we worked out an index of agreement. So basically just how much does that forecast match what we have. We also worked out a Z value for each grouping, and you can think of that as an indicator of how volatile is the outlier. How big is it in comparison to the input data? Yep. And then we plot them. So the index of agreements are quite good. You can see the big peak just above 0.8 is very good, sort of a secondary peak between 0.5 and 0.6. The interesting color plot, so the Z values again being sort of how volatile is your outlier. You can see that there's the big strip at 335 being a lot of the control sort of non-outlier data. So everything to the left of that being the actual outliers. You can see that cluster of pink in the top left is really interesting. That suggests that our model was quite good. It had a good index of agreement for short, volatile outliers, which is quite interesting. So this is just a selection of percentiles, index of agreement percentiles, and sort of examples of the RNN prediction and the recorded flow from the sensors. And then we wanted to improve that slightly. So when you take the difference, I'll go back actually, when you take the difference between the RNN prediction and the recorded flow, that's your model's residual. We looked at those, and we then used Kalman filter again to forecast residuals. So it can do that on a rolling basis. As you get more and more data from the sensors, it improves its residual forecasting. So this is a sort of arbitrary point in time as an example. And we end up combining those two models. So the RNN gives us our mean flow forecast, the Kalman filtering for residual, and we add them together to get our final flow forecast, which for the most part is quite interesting. It is sort of showing that for the outlier data as well as the normal non-outlier data, it can forecast well. So yeah, we have quite a few things that we want to try to sort of tweak the model. The ratios of outlier to non-outlier training data, we want to try that, mix them up. We potentially want to fiddle with our minimum outlier length. It's 5 hours too short. And we've also got more data from Yorkshire Water. pipe properties, material, age, that kind of thing, which we want to be able to add to the RNN as inputs to sort of improve the forecast modelling, so that ultimately the idea is we'll have a model that can give you early warning, probability-based early warning of whether or not you're going to get leakage in a given DMA for a given time frame. So yeah, that's...
Our next speaker, Markus Hofmeister, PhD candidate at the University of Cambridge, presenting Universal Digital Twin, cross-domain flood assessment in smart cities using knowledge graphs. Please.
Thank you for that introduction, and welcome everyone to my presentation on my PhD, or one of my PhD projects. Quick content about the presentation. We start with a short background, then I will introduce you to our understanding of a potential universally digital twin. Then we discuss the cross-domain flood assessment, and I sum up with some contributions and outlook. So what problem are we actually facing? So the Environment Agency has, in their 2008 flood assessment, estimated that 2.4 million properties in England are actually prone to flood risk by rivers or coastal waters. And in addition, there are more properties kind of potentially affected by flood from surface water. So that means 1 in 6 properties is basically at some sort of risk of flooding at some point. One potential coping strategy is an increasing number of sensors, and then based on that have improved prediction of floods and potential kind of prevention measures. However, that basically means that you have an kind of very intertwined system of physical sensors and other kind of actuators together with more and more software tools, either being kind of IoT or being iOS. But the problem there is that a lot of different data streams are not really interoperable with one another. So you have different schemas, different types, you have kind of different reporting frequencies, and so on. And so you have a lot of friction in kind of exchanging the data. And furthermore, it's also one data stream in one domain might have a different kind of interpretation in different domains. So for example, if a sensor kind of reports a water level, and it might be kind of intrinsic information that is kind of an instantaneous value, and in another domain, you normally look at kind of average values. So there's a lot of ambiguity in that. A potential solution to that is using ontologies to represent data. So ontologies basically provide a conceptual representation of a particular domain. So it means you specify concepts which are relevant, and also then the relationships between concepts. And if you represent data using ontologies, you end up with kind of directed graphs where you have like nodes which represent entities, concepts, or data, and then you have edges which represent the relationships between those. Those graphs are called knowledge graphs, and they can be distributed all over the internet. That means they can be in all kinds of sorts of places, and you basically just link to information in all of these places. That basically means you have linked data, which helps to information to be kind of discoverable all over. It doesn't matter where it is actually stored, and you can infer how the different data and instances relate to one another. A couple of years back at our research group, we started the World Avatar project, which basically, I assume you can infer from the name, kind of has the aspiration to represent or provide capability to represent all sorts of aspects as digital twins. So that means you don't only have data in the knowledge graph and the definitions by having like the ontologies and the concepts, but to also provide computational capability in the forms of like smart kind of software tools, which we refer to as agents, which are themselves also marked up semantically. That means you don't only have the data kind of discoverable in the knowledge graph, but also what you can actually do with the data. So all the computational capabilities. That means everything is connected, and that potentially helps to overcome a lot of those interoperability issues. So how can we actually apply it to a potential use case in the UK? So the UN Sustainable Development Goal 11 kind of emphasizes that disaster risk response and assessment is an integral part of like social and economic development. And so there's a lot of information out there. For example, the Environment Agency frequently kind of releases flood warnings and flood alerts. And so we thought about how we can use that information together with other publicly available data to provide continuous impact assessment of potential floods. To achieve that, you first of all need to conceptualize the data. So that means you need to develop the ontologies to represent all the relevant data sources and how they are interrelated to one another. Then you need to instantiate the data also on a frequent basis, because a lot of the data is coming from APIs and provides continuous updates. And then basically on top of that, you want to have also autonomous software agents actually making sense of the data, making inference, making all the work, all the heavy lifting, which you don't want to do manually. So in terms of developing the ontologies, we, for this use case, developed 3 new ontologies. One to represent like flood events and flood warnings, then also like built infrastructure like houses, uses of houses, the property value and so on, and environmental observations, being weather data, which is relevant, being flood water levels. The data sources you can see Met Office, Environment Agency, Her Majesty, Land Registry, Ordnance Survey, mainly publicly available data. When developing those ontologies, we try to leverage the value of linked data by reusing existing ontologies, which have been published, of course, and then also kind of making our ontologies publicly available in a modular fashion, so that you basically start with a very generalizable top-level ontology and you refine, just for illustration purposes, if you need a more domain-specific representation. You then can actually use those ontologies by the so-called software agents to instantiate the data coming from the APIs. This is what we refer to as input agents. And so that means that our knowledge graph remains current in time. And then you have all the agents acting autonomously on those instances. Basically, you can actively trigger them by sending an HTTP request over the internet, or they just trigger themselves by observing parts of the data and then inferring any potential updates. Let's skip that in the interest of time. So in terms of how do the agents actually trigger themselves to perform potential updates, there we have developed a derivation framework, as we call it. So you have basically software agents in the knowledge graph, which kind of observe particular information. And whenever that information is kind of updated, for example, in that case, if there is a new flood warning coming in, that software agent triggers a new kind of assessment of the number of affected buildings or the estimated value of those buildings, for example. But of course, it doesn't stop at one level. So that potentially means that a property value estimation could be calculated by a different agent, right? So that means once there is some sort of new update in the knowledge graph, you have an entire cascade of potential agents acting on that data. That makes basically you represent dependencies intrinsically, and you ensure that you have consistent provenance information in all your instantiated data. All right, so how does that look like? Just to give you some ideas. So we developed a map-based visualization where you basically have all those data in, and you, for example, can just look at all the environmental sensor observations next to your home, like all the weather data which is there. You have air quality data which is there. You can also look at, as said, the water level data which might be relevant. There's also some information about the time series, of course. You can look on all your air quality. All the data has been there publicly, but it always was provided in some sort of isolated silos. And here you have basically a one-stop solution to see all that. You can also see, for example, if one water level sensor is indicating a high reading and also an increasing trend, you can kind of get an understanding, okay, that might be something you want to observe. You see, okay, it's related by being located at the same river to another station. You can figure that out. and then see what further station you might want to focus on. Using the very same infrastructure, a different project has been conducted by my colleagues at CMCL, which is basically, it's called CREDO, Climate Resilience Demonstrator, and that is basically understanding the impact of a potential flooding on infrastructure systems. And they looked at energy infrastructure, they looked at telecom infrastructure and water infrastructure. And the interesting question is, how would a failure in one of the systems potentially propagate all over to the other networks, right? And what you can see here in blue is kind of a flood depth map where, yeah, of a potential flooding scenario. And then here you see all the kind of assets and how they are related to one another. And let's just look at this electricity substation. You could see that here, even though the power state is kind of false, so that means it is not in operation, but the actual flood depth at that location is 0. So you might question, like, why is it actually experiencing a failure? And then you see that it's related and powered by 2 other substations. So it kind of has a redundant electricity supply, but you can then figure out, okay, if you look at that station, that is actually quite deeply underwater. Checking the other option, okay, that one is flooded as well. So you kind of understand if one aspect fails, how that propagates all the way through. And that is all done by those, yeah, autonomous agents. And lastly, before wrapping up, is basically if there's a new flood warning coming in, that's getting instantiated as well. And then it is automatically estimated, okay, what kind of buildings are actually affected by that? How many buildings are in that area? Like how many people are in that area and might potentially experience any issues? What kind of property value is potentially at risk if you look kind of, yeah, all those property values. And interestingly, you can also understand for that particular area, is there actually an increasing trend in flood warnings, similar to when you analyze accidents, that you want to understand not only the accidents themselves, but the near misses to actually prepare your strategy and mitigation measures. To wrap that up, so we have developed a couple new ontologies to instantiate yet isolated data. We have demonstrated the value of linked data and autonomous agents for a flood assessment use case and provided a proof of concept for this derivation framework. Some things which we want to do is, of course, yeah, incorporate increasing amounts of data, of course, and also kind of extend the current impact assessment, as this is just, as said, a first proof of concept. Thank you for your attention.
Thank you very much. So the final speaker of the session, Dr. Blunden, researcher here at Southampton University, also my colleague. Comparison of 2 methods for assessing rooftop for PV suitability.
Apologise to anyone who was expecting to have an air quality talk. That'll be next year, so just didn't quite do it in time. So instead, we're looking at 2 different methods of assessing rooftops, and applied in 2 very different cities that have already been introduced in this conference, Jeddah in Saudi Arabia and Southampton in the UK. They're both globally important ports, but the similarities sort of end there. Since sort of mid-20th century, Southampton's population has sort of grown at a sort of very low, sort of steady rate outwards from the centre, whereas Jeddah sort of exploded from the 1960s, where the population was similar to Southampton, but now it's around 4 million, so it's an incredible growth. And as we've heard, the climate is somewhat different. Go ahead to that, go back again. Yeah, so here's a graph of PV output on the same scale, and you can see that Jeddah is obviously located near the Tropic of Cancer, so you actually get peak PV outputs around the equinoxes, and it actually drops down towards June when it's hottest. But nevertheless, it's very high throughout the entire year. Yet, you'll find a lot more domestic PV in Southampton than you will in Jeddah. And if we look at carbon reduction targets, for a contrast, you can see this was looking at a sort of fabric first building refurbishment estimate of total. So these circles are to size. So if we look at the total CO2 emissions, scopes 1 and 2, and what could be achieved by building refurbishment, it's significant, but it's still quite a small chunk. So can we build on that by sort of micro-generation within the city? And as we know, the Kingdom of Saudi Arabia has great challenges in terms of reducing its CO2 emissions towards 2050. But nevertheless, there are very ambitious targets of building gigawatts of photovoltaics. This is mainly focused on the sort of mega projects, huge arrays in sort of desert locations. However, as we've heard, then you have issues of land use and also of the strengthening needed for the electricity network in order to, the pipeline to get all that power into the places where it's used in the homes. So, back to this. So I'm going to look at two different approaches to rooftop assessment. The first was applied in Southampton, and it's kind of I'll say a white box model, so it's understandable and based on LiDAR data and sort of viewshed analysis. And the second one is using a sort of more grey or black box model using machine learning techniques. Just to compare the two methods, so the first method, which is sort of a white box model, it's easy to explain the results and the methodology to people that are not sort of specialists in the subject. That's definitely an advantage. However, it requires some specific data sources which may not be applicable everywhere or available everywhere. In the UK, very high resolution LiDAR data is available openly, basically everywhere. But this is not the case around the world. So in the second method, it's much more of a closed box, but however it can be applied anywhere, although it is computation intensive. So this was a methodology which is applied to Southampton, and it has since been spun out by my colleague Phil Wu into a company called Absola. And basically, you take the LiDAR data, which is the point cloud with no other information attached to it. Then you have a building footprint and some information about what that kind of building is. The two don't usually match up very well, so you have to do some clever things to identify what's a roof, what's the edge of a roof, and then put a line boundary around that, and then conduct some GIS analysis to see what solar resource will be available for that particular orientation and azimuth. And then this gives you the results for the whole city. So this is just showing what LiDAR data looks like on the LiDAR. And you can show that the difficulty involved in picking out the edge of a roof, it's not always immediately obvious from the data. And then shading is then computed using viewshed techniques, and that can take into account all the kind of plant on the roof and that sort of thing. And then you run the computation, and then you get the solar radiation. And this is using standard tools. And this is part of Southampton with the St Mary's Stadium there. And then you crunch that all together, and you can get results for a whole city or even a region. And we estimated around 150 megawatt peak could be installed in Southampton, total installation capacity, which could generate up to 130 gigawatts a year. which would be about a third of the domestic energy electricity consumption. And that can be further broken down by census areas and correlated with other variables, socio-economic factors, social housing, and that sort of stuff. So moving on to the second method, I'm not a machine learning expert, unlike Lauren, but these tools have come on leaps and bounds in the last few years and available to non-specialists like me. So we used, within ArcGIS Pro, we used the mask RCNN model, which is partially pre-trained on millions of images, and then the last few stages are trained using your own data. And so this is a sort of image segmentation approach, so it can pick out. The good thing about this particular model is that even if you've got roofs that are kind of very close to each other or touching each other, it can actually pick out different instances, which is, it's amazing, really. So we took a one area for training the model, and this is just a small pilot study. We're aiming to expand this out to the whole country. But so we took a training area, manually digitized the rooftops that were suitable, and then trained the model, and then applied that to a completely separate area of Jeddah. So we manually digitized the rooftops, we run the model, and we see that the validation loss kind of drops away smoothly, and it doesn't do any strange things, which sort of indicates that we're not overfitting the data too much. And then we apply it to the test area, and we see whether it can pick out suitable roofs, and we get some false positives and some false negatives, but overall the results are pretty good. Occasionally the area of rooftop is less than half of the actual roof, and we call that a false negative. And we have these precision and recall things. I think the precision penalises false, let me get this right, is it false positives, and then recall penalises false negatives. But in both cases the results were good, which is kind of what you'd expect because all the roofs are quite similar in the city. But we want to take this further and start to identify things like AC units on the roof, satellite dishes and stuff like that, which might be difficult to move and might reduce the capacity that you can install in roofs. And so we feel that that going forward it's a good, widely applicable method, and we'd like to develop sort of more integrated tools for that approach for solar resource assessment. Thanks.
Thank you very much, Luke.
So we have, I think, a few seconds for questions. We have any questions? Otherwise, I have a lot of questions for all of you. No, please, if there is someone in the audience. Yeah, okay.
Hello. I'm just interested, Luke, you touched that on the overtraining of the data with your new data set. So Lauren, really, how do you deal with seasonality or week level, as you saw the pattern, or seasonality through season, especially of water usage, and not having too much data so you kind of overtrain your data with? So how do you deal with that aspect?
Yeah, I think that's why I skimmed over the detail of it, but those cells, that's why it's really important to have the long-term memory so that the model, the previous, obviously it seems straightforward that the previous flow data point is going to influence your next flow data point, but also that seasonal trend is really important to capture, and so having the long-term memory extracts just the important bits of all the previous data points so that you can kind of keep that pattern going. And that's why I think makes it sort of potentially want to refine it to look at the different outlier sort of lengths as well. Do the good performance at the high volatility is interesting. It'd be interesting to see where your input data has more of those days of fluctuation, how does that impact the forecast? Yeah.
Okay, do we have a question? I have a question for Markus. So I think it's very interesting the idea of having systems of models that can fundamentally cooperate and be able to tackle multiple problems, because of course at the city level we can have a series of cascading failures if something goes wrong in one place, and then how do you see, because we have of course today a lot of development in individual domains, so we can have efficient machine learning tools that can tackle individual problems. But of course, the whole premise of a knowledge graph is having a good ontology that can really capture the essence of each individual domain and be able to connect them. So how do you see technical standardization as a way to accelerate this process of ontology creation? So can it help, do you think, or is it something that is better to build from scratch from...
Yeah, it actually would make a big difference, because the problem is when you do some literature research, because what you want to do is reuse existing ontologies where they are, right? Of course, you want to kind of quality control and screen them whether they are fit for purpose for what you actually want to do. But a lot of the time you see that people develop ontologies, but they do not make them publicly available. And then the question is like, why do you actually do all that effort if you don't share it? Because the whole idea is you want to link it up with other stuff. So in the work I've presented here, 2 ontologies were actually made from scratch, because you always have, I mean, there are different approaches, right? You can always go top down, where you think about very conceptually about what do you want to represent, and then it becomes very philosophical how you want to actually conceptualize the data, or you do it bottom up, where you also consider the data you have available and then kind of think about what is the MVP to actually represent that data conceptually. So we built 2 from scratch, and the third one we basically reused existing ontology, but only parts. Yeah.
Okay, thank you. And the other question is for Nick, and it is quite closely related, because I think the least information principles that you were talking about could be maybe using ontologies, but do you think it's, because I like the principle, but it's not more difficult to do it in design terms, because you need to be able to synthesize your problem and to decide what is the least amount of information that can make you effective, make the job done, and at the same time with the minimal effort.
So a couple of things. So my background, my PhD is actually computational linguistics. So when people talk about ontologies, I get all shivery. In that usually the web abstraction, everything we tend to do is bottom up. You statistically derive it based upon real world use. And to some extent, that is the answer to your question, is, you know, when you're doing something, when you're actually writing a function or a piece of code, you know exactly what piece of information you need. I mean, somebody might give you more, but if you start talking about ontologies, you'll get mixed up in a circular list of abstractions. But if you just look at the function you're trying to do and identify what is the minimum piece of information that I need to achieve the objective, the answer just pops straight out. And that is the real mechanism via which you should define that least. Because to some extent, those 2 concepts are tied. The least privileged concept assumes that you're able to identify functionally and transactionally for the thing that you're trying to do exactly what the piece of information that it is that you need. And the fact that it might be coming in from different sources, from different people, and there could be 3 or 4 different ontologies that partially match up, are just abstractions and statistical sort of like variances. But at the atomic level, it's a very easy problem to solve.
Thank you. Do we have any other questions from the audience? No? Don't think so. Okay. So we have our keynote from.
Thank you.
Okay, you can.
Thank you, guys. Thank you very much.
Thanks.
Right, we have our last keynote of the day, and hopefully Dr. Alan Whitehead, who is our local MP, and Alan is also the Shadow Minister for Energy and the Green Deal in the UK. Alan has been the leader of Southampton City Council for a long time, and also the MP. Was it 25 years? There you go. It's still young. And basically, Alan is really a major driver in relation to interactions between policy and knowledge-based and also local authority, and also getting industry as a whole to be integrated within the net zero mix that we have. Alan, the floor is yours. So you can use the clicker. And there's a pointer there.
Well, good afternoon, everybody. I'm very pleased to be here to finish off your session this morning, hopefully with some thoughts about how we relate policy drivers in the UK, particularly as it relates to heat, to the situation in Southampton and the imperatives that we're going to have to undertake in our part of the world as a result of those policy drivers nationally. And of course, when we look at heat in Southampton, then we'll see that there is apparently not a problem. The city is well heated generally. There aren't any bad spots in the city as far as access to good quality heat is concerned, either for domestic or for commercial industrial properties. And indeed, from a point of view of how well the city does and can do in terms of its heat supply. Unlike parts of the UK, the city is completely connected to the gas grid and also well connected to electricity grids, by which I mean both high-level transmission grids and distribution grids as far as electricity is concerned. And what that means is, in terms of the security of the supply, the management of the city's supply, it's a pretty good and straightforward process. And indeed, we'll see across the city that something like 90%, particularly of domestic properties, are getting their heat from gas and deriving their heat from boilers within their homes. We do have in the city a number of district heating schemes, which you may have heard about already in some of the presentations to this conference, but in general, Southampton is mainly based for its heating on gas boilers and gas-derived heating in general. And something I want to dwell on briefly in terms of the efficiency of that heating. The energy efficiency of Southampton's building stock is marginally above national average. There are very few single-skinned homes in the city. Most of the properties are cavity wall properties, a number of which have had energy efficiency measures undertaken on them.
therefore the general picture, although I will come to in a moment some of the caveats on that, is that Southampton's housing stock is fairly energy efficient, which is potentially quite important in terms of some of the changes that we're going to have to look at in the not too distant future as far as the heating in Southampton is concerned. So just, I don't think can see that very well, but you can see in terms of, this is electricity grids nationally. The red ones are the high level grid connectors, and you can see we're there, so there's good supply of high level grids coming in our part of the world. We're not likely to have severe overstrain on the grid system as the country electrifies in general, and whilst there may be some strengthening necessary, particularly say as far as the port is concerned, in general the supply is reliable and reasonably secure. And similarly, as far as gas networks are concerned, we can see here there's a good close high level gas network pipeline going close to the city, and therefore no particular concerns as far as the security of supply of gas is concerned in the city. So all is well right now, you might say, except of course, final slide here in terms of Southampton's position. That is a very brief look at the relative SAP ratings and SAP rating bands of Southampton's housing stock. And you can see there that, yes, there are a number of properties in a pretty bad way as far as Southampton is concerned in E, F and G SAP ratings, but it is below the national average, and that, as I've said, is particularly because Southampton's housing is generally a little more modern than the national average, and some of the pre-1920 houses that were built without skins, stone-built houses, don't exist in Southampton, and you've got therefore a marginally better call on different SAP bands than the national position. Marginally more A homes, marginally more B homes, marginally less C homes, and substantially less D homes, and marginally less E and F than national home structure. But that does disguise one or two things, as I said, which we need to address. But of course, the net zero imperative now in national policy considerations means that all of that has to change. And as you know, the government has now adopted a net zero strategy for the UK. That is, by 2050, we will be in a net zero position as far as our national emissions are concerned. And whilst that does mean there will be carbon overhangs, those carbon overhangs need to be absorbed on a net zero basis by net negative activities across the country. So the overall framework, as far as heat is concerned, is that heat has to work within that net zero imperative. And whilst there may be some little leeway, the net zero imperative means that there is very little room to walk around in within categories. And I think delegates may be familiar with the situation that was the case until a little while ago, which is the emissions imperative was net 80% reduction by 2050.
which, at least in theory, did allow for some walkabout between sectors, so that some sectors could emit rather more, other sectors could emit rather less, but net zero means that you've pretty much got to tighten up sector by sector with very little walkabout room within it. And of course, as far as the country is concerned, we are, as a nation, very bad at heat decarbonisation. And only something like 5 or 6%, for example, of the heating that is provided nationally is electric. It's pretty much all gas, some oil and coal still for rural heating, and therefore an enormous gap to make up nationally as far as heat is concerned to get to that net zero imperative. And the government has introduced a heat strategy. I personally think it's a pretty bad heat strategy, hence what I put such as it is. They've recently produced a heat and building strategy which does attempt to grip this from a national basis as far as reducing heat in towns and cities and across the UK down towards that net zero imperative, and envisage very substantial progress being made in that by the mid-30s. And in pursuit of that, one thing the government has introduced is that the installation of new pure gas boilers will effectively be outlawed after 2025, which, bearing in mind we are in 2022 right now, is quite an ambitious aim. But that, of course, doesn't mean that gas boilers are all going to be taken out and shot in 2025. It means that over the lifetime of boilers in the country, 1.7 million boilers exchanged usually on a distress basis each year in the country. As the lifetime progresses, then there will be no new gas boilers installed, and other things will need to be installed so that by the early 2040s, mid-2040s, then the cycle will be complete and all those boilers will have been reinstalled with other boiler arrangements. And the government envisages very much that this will be accompanied by mainly the electrification of heat. And they have announced the rapid aim of deploying heat pumps on a much wider scale. They have currently a target of 600,000 heat pumps per year by 2028. My personal view is that is very unlikely to happen under present arrangements because of the lack of progress on heat pump deployment so far, the lack of heat pump engineers that we have got at the moment in order to install the heat pumps, and indeed the problems from a voluntary point of view of households readily scrapping their boilers for more expensive heat pumps and willingly putting them in even if the target is there to do so. The government is also looking to inject hydrogen into the gas grid, and it is generally thought that you can do that up to 20% to decarbonise the gas grid in situ, as it were. But I think, as is generally known, if you inject more than about 20% of hydrogen into the gas grid, your boilers and various other things start going wrong, i.e. Above that injection level, the heating equipment ceases to function very well and has to be changed, particularly the jets on boilers have to be changed in order to accommodate more than 20% of hydrogen in the system in general. Now, of course, that has been done in the UK previously, the transition from town gas years ago to natural gas involved precisely that sort of changeover. That was done on a national basis, but at the moment there hasn't yet been a firm decision to go above 20% hydrogen in the system, and so very little work has been done in terms of actually either producing hydrogen-ready boilers for installation when boilers break down, or indeed setting up a national programme of transfer of boiler capacity to take that initial additional amount of hydrogen in the system. They've also, in the energy bill that is just coming up, which I will have the pleasure of helping to take through the House for the opposition, is, among other things, a requirement of local authorities to start zoning for district heating, but not necessarily to install district heating, just to define zones where district heating could be good for particular city areas. And indeed, the energy bill will set out a number of trials of complete hydrogen areas where you actually switch the systems off entirely to managing hydrogen for heating overall. And they're envisaging a number of village trials. We haven't got to towns yet, let alone cities, but those will be underway and will be stamped by the energy bill as it goes through the House. So that's the national. Those are the national policy imperatives as far as heat is concerned for the future, and we may pick some of them apart in terms of doability or feasibility or unlikeliness. But basically, that's the strategy framework which we are faced with in cities as far as the government is concerned. So how do we apply those policy imperatives to a real city, and in this instance Southampton? How might this all work? As I have alluded to, Southampton has some advantages in terms of the policy implementation, that we have in the city already 5 district heating schemes, including the very substantial geothermal district heating scheme in the city centre. But I have to say that most of those schemes are run on gas, so you actually got district heating schemes, so you haven't got much further forward in terms of, I mean, they are more efficient users of gas than boilers, but you haven't really got that much further forward in terms of decarbonisation because of the fact that they're mostly gas engines running those schemes. One disadvantage for Southampton is that whilst I said that there is a marginal overall SAT rating advantage over national picture, but it actually does disguise some very poorly insulated houses in the city, and that's particularly the case because, as far as Southampton is concerned, they have a very high homes in multiple occupation sector, which, by the way, do not fall within legislation, for example, on getting landlords to uprate the energy efficiency of their properties, because they're not a single letted hereditament, i.e. people are coming in and letting parts of those houses at different times, and a lot of those houses in Southampton are really shockingly poor in terms of insulation, and since we are at Southampton University, that means a lot of Southampton University students are actually living in extremely poorly insulated homes, and by the time they've got round to complaining about it, they've moved on to the next home in the city. So, looking at the advantages, here's the big district heating scheme in the centre of Southampton, the Southampton geothermal scheme, and that's what it covers at the moment in the city. So it covers some housing, but importantly, a lot of the businesses, the Southampton University, West Quay. So quite a lot of work in principle, for the district heating of much of the city centre is already done. What we don't have particularly as a penetration is an enormous amount of domestic property district heating. And the 5 schemes, one at the university, one at the hospital, General Hospital, one in Woolston, only 2 of those are predominantly domestic property district heating schemes. So there is an enormous potential for district heating in the city. And that's because, among other things, Southampton, I don't have a map of Southampton to show you, but basically the urban area of Southampton can easily be delineated by flying over it and looking down at the air to see where the urban bit ends, and that's the boundary of Southampton, which is a very densely populated city. Certainly very good potential for substantial district heating development, but as we know from how district heating works, you've got to get in a heating network, and you've got to balance your loads on your district heating schemes, preferably between residential, which will vary very much during the year, and commercial and industrial, which won't, so that the scheme itself works efficiently. So if you're trying to develop district heating, particularly for low carbon purposes, out in the city, you've got to do 2 things. Firstly, you've got to join your district heating schemes together so that the load is balanced across the city to a much greater extent. And secondly, you've got to ensure that the schemes work well as far as decarbonisation is concerned, which means that you've got to basically change the fuel that's going into the district heating network. Heating networks are agnostic in terms of fuel, can be easily done, but you've actually got to have the wherewithal where you can do that. Interestingly, Copenhagen, which I visited just a little while ago, is now 95% heated by heat networks across the city, so it can be done. It's, I'm afraid, however, it does seem to be that rather more sensible nations than the UK have done it. The UK hasn't particularly gone very far down the line of district heating in general. As I've said, district heating would, however, need to get off gas. So question, can it be powered by hydrogen? And the answer is, of course, yes. But the issue then is where you get the hydrogen and what colour it's likely to be. Now, we know that Fawley Refinery, just down the road from Southampton, is beginning plans to produce hydrogen, both green and blue. The refinery is connected to pipelines which actually go to Heathrow Airport, go to the Midlands, could reach into Southampton, so you've got a possible supply of hydrogen. But it's also the case that National Grid Gas is planning skeleton hydrogen transmission pipelines using mainly redundant existing gas pipelines to start bringing hydrogen on a transmission basis to major industrial clusters, one of which is Southampton. But whilst they plan to reach Southampton, I understand there are some problems with how you get the last leg of that skeleton transmission down to Southampton. As far as electricity is concerned, then there are indeed issues for Southampton, but not enormous issues, both in terms of supply and capacity. Clearly, the very substantial additional demand on Southampton that will arise from increased electrification of functions, port activity, electrification of buses, etc., will need some new high-level power sources to maintain, and it may need local cabling strengthening to service them. But there's also the possibility in the city of actually aggregating local supply, such as solar, or indeed new forms of supply, such as hydro, in and around Southampton itself. And there is, of course, although this is not in the energy bill, but is something that certainly we would like to see in the opposition, the resetting of grid arrangements so that cities effectively have their own local grids. I mean, this is common in Germany and various other places. As you can see from the grid map, where we are in the UK is very much a centralised grid system, as if we still had 80 power stations delivering power to the grid nationally, and then distributing outwards. Now, everything has changed from that point of view, but we're not very efficiently harvesting the decentralised supply of electricity that we increasingly have at below high-level national grid points. So possibly resetting grid arrangements so that cities have their own local grids. We can harvest sub-regional supply, balance locally and send up to the national level to actually ensure that we've actually got a resumption of that efficient supply that we have been so used to in the past under very different circumstances. So I'm conscious I've rather gone over my time, so I'll just very briefly just point out some prescriptions and conclusions for Southampton. I think Southampton probably can't go full hydrogen, but substantial gains can be made by using, as I said, hydrogen to power district heating, provided we can build district heating in the first place. And indeed, there's the possibility of hydrogen villages within Southampton for the future, provided you have that secure supply. But we do need that very substantial programme of new district heating systems required, and I am rather concerned about the lack of progress and support from central government for such programmes that will be necessary, particularly where you're conjoining existing schemes. And finally, a big programme, which I think is a complete no-brainer, of energy efficiency upgrade in homes, not just because that's a good thing in terms of climate change and making sure that we are as mean as possible with our energy supplies, and we are tackling fuel poverty and making bills cheaper, but among other things, to make them efficient enough to put heat pumps in the first place, because that is a problem with heat pumps, that if you have very inefficient homes, the heat pumps don't work as well as they should. So an overall city treatment basis to get us ready for the new dispensation as far as heat is concerned is something that we're going to need in the very near future. Southampton is quite well placed to do that, but I do not at all underestimate the problems that lie ahead for Southampton. And I would say, by the way, that those are not just problems for Southampton, those are problems for cities throughout the UK, which need to be managed on an urgent basis.
Well, there is some time, some questions, if you're happy to take some. You brought us back full circle. On Monday we had the city heating forum, and now you bring it really to light with the issues around Southampton. Thanks very much. Any questions from the floor? They're all hungry. Andrew.
Hi, Andrew Waggett, Portsmouth City Council. What do you feel is the role for local authorities in the delivery of energy efficiency and decarbonisation of heat generally in cities, particularly in domestic? And if you think there's a role for them, what policy steps do you think should be taken to strengthen their hand in the delivery of that?
Oh dear, how long have you got for that? Yes, I mean, I think it will be apparent in terms of the translation of the national policy imperatives to a local level, that there's a big gap there as to who actually does all this stuff. And local authorities, particularly city authorities, are absolutely the people who will have to do it and need the powers to be able to do it properly. And certainly, and I've mentioned the continuing centralisation of energy systems in the country, that does, among other things, tie local authorities' hands quite considerably in terms of giving them the wherewithal to plan properly as far as their areas are concerned. So I would envisage not only greater powers in planning arrangements, Obviously, a lot of resource devolved to local authorities to be able to manage circumstances according to the best combinations that they're going to be in their particular areas. So, as we can see from the national prescriptions, they are just that, national prescriptions, which don't particularly relate very well to national circumstances. I mean, for example, and I've mentioned the fact that Southampton, in terms of energy efficiency, doesn't have that many single-skinned homes, and therefore the energy efficiency task for Southampton may be rather easier than some cities. But Blackburn, for example, I think has about 80% of its homes are single-skinned, and actually will need whole house energy efficiency treatment, which will mean that the circumstances will, of course, vary very much between authorities, and it's absolutely the local authorities that actually need to be at the forefront of making those local circumstances real as far as national policy is concerned.
Okay. Alan?
Alan Wilson from Net Zero Group. Very aptly, or maybe not aptly, titled presentation in the middle of what's now been declared a national emergency for a heat perspective. So at the moment we don't need to be too concerned about heating. My question is this. Last 3 days there's been so much knowledge shared in this room. Really amazing stuff. How do we actually accelerate the transition of that knowledge into action? Because the task is enormous. How do we make that happen? It just feels like we've not got enough time to do what we need to do.
Yes, I mean, I concentrated, because we're in Southampton talking about evolving cities, how Southampton as a city might evolve in this respect. But of course, you're absolutely right that overall, from a national perspective, we may well be thinking positive thoughts about Southampton, but meanwhile, all the policy development is actually grinding along at a glacial pace in the country as a whole. So, and indeed in Southampton, we're only going to be as good as that policy development is concerned and what it lets the city do. So, a key point number one is that actually we've got to get the plans in place to be able to get us to do these things at speed, and that entails, by the way, the central government getting off the idea of not picking winners. One of the signatures of UK energy policy is, well, you're technology neutral, you don't pick winners, you just set frameworks up and you allow the market to decide which of the various technologies they're going for. You will underpin some technologies like CFDs for offshore wind just to get the market going, but you don't actually prescribe much more than that. Well, we've got to stop doing that as a country as a whole, and we've got to say, here's our best shot at the things we know are going to work one way or another, and even if they don't work perfectly, then we will at least made a lot of progress in getting them into place. And I mean, that is where I'm particularly concerned from a national point of view, that, for example, the government's faint-heartedness, not about heat pumps, but about how quickly you get heat pumps in, and what you do need to do to support them, is an example of that sort of faint-heartedness towards particular technologies. We're very clear that whatever outcomes we're going to get as far as heat is concerned, heat pumps will probably be about 60 to 70% of the total solutions, as it were. Heat networks about 25, this adds up to more than 100, 20 to 25%, and hydrogen the other 20 to 25%. So we know that's going to be the case, so damn well get on with it, is my prescription nationally. And we can have some theological discussions about how heat pumps work best in some places and not in others, and where hydrogen should be and where hydrogen shouldn't be, alongside the development of various things as they go forward. And yes, we'll make some mistakes, but it's just a question now, 28 years to 2050, and that's actually less than 2 boiler replacement cycles, for example. So that's the sort of imperative that we've actually got to work on.
I think Jamwell gets on with it. Sorry.
On that SharePoint, maybe impressive. I think we need to have a stop for that. Otherwise, Alan, you'll be late for your interview and also for your a little bit to eat, perhaps. And our lunch may be cold if we don't go out quickly. I'd like to take this opportunity to thank you so much for being here, Alan, and taking the time to deliver your talk about Southampton. Thank you very much. So we'll see you about 2:10.